So, good afternoon, folks. Thanks for popping back. It is a beautiful Monday. It's a nice weekend out there. Hope everyone got outside and enjoyed it. I know I did. I spent a little bit too much time outside. Got a little bit sunburnt, but such is life. So, last week, we talked about a few different things. Gas metal arc welding, all sorts of stuff. And then we finished it off with a PPE video on Friday. Some of you guys got the audio, some of you didn't. Hopefully everyone watched it on their own. But that is what we had. So today we're going to start a new unit. We're going to start with our basic electric welding, our FAB 1050 unit. And the main focus of this is going to be shielded metal arc welding. So what I'm going to do is today I'm going to run you through a PowerPoint, and we're going to talk about all sorts of things that are outlined in the PowerPoint, all to do with shielded metal arc welding and things in the periphery of that. But let's get to it. So this is going to be available for you in your D2L. What I've got here is bunch of stuff. So basic electric welding, we're going to watch the shielded metal arc welding stick PowerPoint. So we've got this here. What I do to make this easily viewable is I pop this out and I then go to Google Slides and then hit present. And that brings it up full screen, looking good. And this is how I present everything to you guys. So if you want to follow along, please do so. Lots of good info in here, and there will be quizzes on it. That's why we are doing things like recording these videos for your reference material. So let's grab a quick drink here and let's get into it. Okay. Shielded metal arc welding, also known as stick welding. Let's get into it. So during this overview, we will discuss the following topics: the safety related around arc welding, the shielded metal arc welding basics, that's what SMAW stands for, equipment setup, different variables, process advantages and limitations, American Welding Society connections, and national academic standards connections. So lots of different things. This is an American-based PowerPoint, so they're going to focus on things like AWS, which is American Welding Society, and the NASC, which is National Academic Standards Connection. So what we're going to do is we are going to get into it. So upon successful completion of this unit, what we're going to do is we're going to learn how to properly protect ourselves while welding. So that's PPE, things to look out for, lots of other variables connected with safety there. We're going to learn how to set up and operate shielded metal arc welding equipment. We're going to strike and maintain an arc. We're going to make welds in 2 positions. This says 4, but we're going to work in 2. Those 2 positions are going to be flat and horizontal. And you're going to understand a weld inspection process. So we're going to talk about different weld inspection processes, what I look for when judging your welds, what potential employers are going to look for when looking at welds as well. And we're also going to apply the American Welding System electrode classification system. And we're going to take the next step, becoming a certified welder. Well, I'm going to inform you on how to take the next step. We won't be taking the next steps in this class, but if you choose to, I can definitely facilitate that journey into becoming a certified welder. Having done it myself, I know most of the ins and outs of the system and definitely can help prepare you for that. We're talking about safety and stuff. This is a great picture about safety here. This welder is working on a site and they're actually required to wear a hard hat. So if you guys can see here, this welder has a fiber metal hard hat with a, they call them a tiger shield, a tiger hood, just made by fiber metal. And they mount to these hard hats. And that's pretty standard in welding industry to see a lot of these style helmets there. I have a few of them and I fit them with auto dark lenses to make them a little nicer, but they're durable, they're cheap, they're nice to have around. This welder here is dressed up quite nicely. Large gloves, heavy welding jacket, got the head protection here, good pants, cuffs are not rolled up to over top the boots. So a good example of safety here. So let's move on. SMAW safety. SMAW safety is supplemental and does not replace the information found in arc welding basics. So there's a bunch of different units that we go through here. Safety is first and foremost, so that's why we teach it first. But you're gonna have to learn to apply that as we move through and learn more about welding. So understanding and following all safety precautions listed in safety and welding, cutting and allied processes. These are just different units that are associated with this Lincoln style of teaching. But basically, we're going to understand how to operate this equipment, how to operate it safely, and how to read the labels on the equipment, the consumable packaging, and how to properly set things up using the instruction manuals. Also, we're going to learn a bit about MSDS sheets. That's material safety data sheets. For every product we have in the shop here, I have a material safety data sheet. I've got a big, large binder. I spent, numerous hours this year updating it because I've changed the way I do things in the shop, and I've added some materials and removed some materials. So if we were to have an incident and say get something in our eye, one of our substances, we can pull that material safety data sheet from the binder, have a read, and it tells you how to properly address many situations involving that particular chemical or cleaner. And say, if it's in contact with eyes, flush eyes, call poison control, it'll tell you what to do. Yeah. So fumes and gases, we get a lot of these in the shop, mainly fumes during the shielded middle arc welding unit. Gases, not so much, but we'll try and avoid dealing with gases because if we are creating gases, they're most likely unwanted. Good example of that would be chlorine gas. That can be created by exposing a chlorinated brake cleaner to UV light and pretty much creates a phosgene gas or a chlorine gas. And yeah, that's no bueno, no good at all. So we don't want that. That's why I don't keep those type of products in the shop. All right, so fumes and gases. Fumes are going to be the big focus here though. So when we weld a stick, we create that arc plume. That's that smoke that's coming off the rod. We just don't want to stick our heads in there. Firstly, we don't need to. Secondly, gets the front of our helmets all smoky. We can't see very well. Thirdly, that stuff is being breathed in. That's entering your lungs and your sinuses and just, making your systems do more work than they need to. So we're going to keep our heads out of these plumes. That's a first pretty much big protection there. We have additional measures in place here, but I like to teach it from the basics and how to protect yourself without relying on safety measures. Because really, when we get out to the field, it's going to be up to you to protect yourself and determine how that's going to look. In our shop here, we do have some great big fume extractors. I've got two really nice sets. I've got a set for the back booth and I've got a set for the front booths. And we've heard those turn on. They're super loud, but they take those fumes right out of our space. That way, we can work in this environment and focus on welding and keep our health intact. Lungs are no joke. We want to keep those as good and clean as possible. It's just going to be easier in general. It's just good practice. In the older days, we weren't so cognizant of our own health. It was, finish a job at whatever cost. Nowadays, there's a big shift in focus onto maintaining physical health, mental health, and just overall more focus on the person performing the work instead of just finishing the job at any cost. So that is really nice, and it creates a much better environment to work in nowadays. But I use those fume extractors to take all the fumes out of the shop so they're not affecting you. If you find you are affected still, we do have respirators in the shop. The systems I have are more than adequate, but if you are particularly sensitive to the smoke, we can set you up the respirator and get you fitted for it and make sure it works well. Another thing we need to worry about is electric shock here. So welding is an electric process. So we need to figure out how to keep ourselves out of that loop. And in class, when we set things up here, I'm going to show you all the parts and pieces, what to watch out for, where you could potentially put yourself in the loop of electricity. Generally, it isn't that bad. I've shocked myself numerous times. It's not pleasant, I will say that, but I've been fortunate to never receive a bad shock. Bad shocks can obviously, actually any shocks really can, disrupt your natural heartbeat. It's called arrhythmia. If you potentially have a heart issue or palpitations to begin with, this could, exacerbate that and make it definitely worse. So we want to keep you out of the system. It will happen eventually that you do shock yourself, and I've done it in class even while giving demos. Yeah, but I'm going to make you guys aware of how to avoid that. So big thing, if we're working for a long period of time, our hands get sweaty, our gloves get wet. If we're wearing thinner gloves, those gloves can then become part of the loop. And that could be you're grabbing a rod to change it in one hand, and you grab the electrode holder in the other. That way you're inserting yourself into the loop. It's not a good thing. You could have, be working outside, could be wet, your gloves could be wet, all sorts of things could be happening. Your boots could be wet, you become part of a loop that way. I try and avoid working in overly damp and wet conditions. So best thing to do is keep a dry insulation between your body and the metal being welded or ground. I've had to work in a lot of wet areas. What I'll do is I'll drag something like an old pallet, throw it in the puddle, stand on the pallet. Wood is a great insulator. It is not, it will conduct a tiny, tiny bit, especially when wet, but you have a lot more time before it comes conductive than you would if you're just standing in the water. So arc rays, we need to be aware of those as well. Just like this weekend, I got sunburn. So arc rays are simply UV rays. But there's some more other rays in there too, but UV rays are the major ones, those ones you can see. That's a bright light. Actually, no, you can't see UV rays, sorry. But that's what gives you sunburn. I got a bit of a sunburn this weekend. I work with, I take good measures to protect myself in the shop from UV. For some reason, I don't want them out in the sun. So that's something I need to take into consideration and protect myself a little better from. Because melanoma is not a fun thing. For those of you who don't know what that is a form of skin cancer, which can happen to repeated exposures and bad burns of skin. So what we want to do is cover things up. We got the long gloves, we got the welding jackets. We want that top button up. We don't want the front of our neck exposed or our chest. The helmets have a long enough chin length on them to cover up a lot of your neck, so you're generally fine there. But it's just taking measures to protect ourselves while we're in the shop. So it also says here that we should take measures to pick the correct filter shade. This is talking about how dark you're tinting your helmet. Generally, for shielded metal arc welding, shade 10 is pretty common for operating with. There are instances where I'll operate with a 9. It depends on where I'm working. If it's dark, if I'm having trouble seeing the puddle, the best thing to do is adjust that helmet so it's just slightly too dark to see what you're doing properly, and then back it off one full shade. So if it's shade 11 or you're having trouble seeing things, back it off. You're at shade 10. That should be the good happy zone there. So we're going to move on. All right, some principles of shielded metal arc welding. The American Welding Society defines SMAW as shielded metal arc welding. Okay, it's pretty simple. It's commonly known as stick welding or manual arc welding. I don't hear manual arc welding very much. If you're working in a bigger shop with a lot of roboticized welding or a lot of submerged arc and semi-automated or even automated processes, you may hear manual arc welding when you have to do something by hand, but generally you don't often hear it that much. Process is the most widely used one around the world. So we always see videos of actually, Instagram. Instagram's great for that. Let's make it relatable. So Instagram, you always see these videos, people building these things. Generally, they're pretty useless and kind of a waste of time to build them, but they're neat videos. They always make them out of stick with stick welding. Stick welding is most common around the world because you can actually manufacture your own stick welder at home if you know the basic principles of it. We need a primary coil, a secondary coil, a movable shunt. A lot of people will use different amount of wraps to generate amperage. You need to hook your power up. I do not recommend doing that in any way whatsoever. We're talking big electricity here and danger. So if you are going to be doing some welding, let's just use some proper certified machines. But yeah, Stick welding is the most common because it requires the least amount of parts. So we have our transformer, whatever style welder it may be. We have our ground clamp and our electrode holder. We need some rods and we're good to go. If we were doing a gas metal arc welding process, we would need the gas bottle, the gas handling equipment, such as regulator flow meter, say hose for delivery. Then we would have to have the different parts for the gas metal arc welding gun and the spooled filler wire. So a lot more pieces to that system. Not as portable, not as versatile. So stick welding is definitely more commonly used around the world. And neat thing about it, we've developed some pretty cool rods with it. We can weld stainless, we can weld aluminum, we can weld basically armor plating, stuff like AR 500. We can weld our regular alloys. We can weld some chromium alloys. So pretty neat stuff. So the way it works is current's going to flow through the electrode cable. So we got the electrode cable outlined in red here, through the electrode, through the holder, across the arc, right down to your workpiece. On the work side of the arc, the current flows through the base metal. So that's the stuff here, to the work clamp. And then back to the welding machine. So it's a loop. Starts here on the positive side, goes up through, across the arc to the table, right there to do all of that. That is how that works. And obviously we need our power source. So we plug it in here. Pretty cool little system though. Very simple. Just when worrying about shocks, just don't push yourself in the loop. So we're going to take a little closer look at what happens at the end of the rod when we're actually welding. So what happens is we got all these different parts and pieces here. So the electrode is number one. That's the rod we're burning off. On this electrode here, we see this granular looking material. That's a flux on the outside of the rod. Flux does a whole bunch of different things. This is the core wire here, right in the middle of it. So number two, we have our arc. The arc is basically the electrical bridge between the end of the core wire and our base metal. Across that arc, we throw globs of steel because shielded metal arc welding is a globular steel transfer. We learned about those three modes of transfer in our last unit we worked on. So we had three modes of transfer in the gas metal arc welding unit. We learned that we had short circuit, which was the lowest voltage process, probably up to about 19.5 volts. And then we started talking about globular, which is probably up to about 24.5 volts. And then spray transfer after that, probably at that 25, 26 and up, with 85% argon gas mix to get that ionization. So this is the globular process here. What we have here, number three, is our weld puddle. This is that molten metal that's glowing, it's liquid, it's dancing around, it's vibrating and agitating. That's because the electric arc is doing that. And also serves a couple purposes. So in this flux here, there are cleaning agents and deoxidizers. They get burnt and sent across the arc when this puddle is being, or actually when a weld's being made. This puddle here vibrates and agitates. What that does is it floats up impurities to the top of the puddle. It's that junk out of there we don't want, because remember, this steel, this is only killed steel. This is not high-end steel, but we rely on the deoxidizers in here to help us clean this up and make a good weld. So as this vibrates all around, all the junk and garbage floats up here. A little bit of time passes, your weld solidifies. And we're talking fractions of a second here, not seconds or minutes. But also slag forms on top. And the slag traps all the junk that came out of here and all the waste material from the flux. So slag does a few different things. It traps those impurities after they float up, prevents the cooling of our weld. We don't want rapid cooling of our weld. And basically it's, helps shape the bead a little bit too. But yeah, as this rod burns, there are gas formers in this flux as well. They provide us with shielding gas because we don't want our atmosphere. Our atmosphere is what, 70% nitrogen, 19% oxygen, 8% CO2, something like that. There's a few other things in there, all in small amounts, but I think that's the majority of it. I don't know the exact atmospheric composition, but I know we're pretty close there. So we want to keep that out of this zone. So everything here is basically forming this gas, keeping it out of here. That's why we don't want to have our extractors too close, because it might suck the shielding gas away. So here is a little breakdown of the electrode. So we got a metal filler, core wire in the middle, talked about that. Our flux here is called the crucible cup on the end, that's how it burns. But the core rod, core wire is kind of what I call it, carries a welding current, becomes part of the weld. Flux coating produces shielding gas, can provide additional filler, some rods in the 20 series. So if we're talking 7024 versus 7018, the one designation on 7018 means it's an all position wire or rod. You can use it flat, horizontal, vertical, and overhead, no big deal. The 24 designation, you see that? Use it in 2 positions, flat and horizontal. In the flux of a 24 rod, you'll notice it's quite heavy and usually has a brown color to it. That's because it contains a lot of iron, That iron melts, becomes part of your weld. So that's how you make a bigger weld without having a huge core wire. You try and take that vertical or overhead, light's going to suck. I'll tell you that right now. It's not designed for it. It does not do it well, if at all. And it's just going to create mayhem and chaos. So an arc occurs when the electrode comes into contact with the workpiece, completes the circuit, like turning on a light. When you flick a switch, basically you're connecting a circuit. This is the same thing. What you're doing is you got the current waiting right here. You bridge the gap with the arc, boom, turns on the light, circuit is closed, and that rod will continue to burn until you stuff it out or you burn it all away. The electric arc is established between the space, the end of the electrode. Yeah, cool fun fact here. The arc reaches temperatures of 10,000 degrees Fahrenheit, which melts the electrode and base material. I will be back in just 1 sec, guys. I got someone here. All right. So cool thing is this weld puddle here. It's really nice picture of it and it helps kind of make things a little more clear. So as the core rod, the flux coating and work pieces heat up and melt, that's due to the arc. We see this bright arc right here, forms a pool of molten material, which is this right here. We call that the weld puddle. The weld puddle is what a welder watches and manipulates while welding. I don't watch my rod in any way. All good welders are going to be watching their puddle shape, how it reacts, what it does, tells the welder how the welder's doing. It kind of gives them feedback. We make adjustments by looking at this. I can tell you right now by looking at this puddle, this welder is traveling fairly slow because he's got a wide puddle. So the slower you go, the wider your puddle is going to be. But he's got a good consistent travel speed because we can see that kind of arc shape here, that crescent at the top. That's what we're looking for. We want that nice kind of rounded shape. So with TIG, a lot of people say, oh, a stack of dimes. So if you took a stack of dimes, you laid it over, how they overlap, it's kind of what people talk about. This kind of crescent shape here is what you want. That tells you that you've got a good travel speed. If it's more shaped like a V, means you're traveling a little fast. So basically the shielding gas is formed when the flux coating melts. So this flux coating here melts. It protects the weld puddle from the atmosphere, preventing contamination during the molten state. We talked about that. So we got gas formers in here, cleaning agents, maybe additional filler metal. And the gas formers create the shielding gas, allows all this to form in its happy little home. So the shielding gas protects the molten puddle from the atmosphere while stabilizing the arc. Helps the arc stabilize too. That's good. As a molten weld puddle solidifies, it forms a joint or connection between the two pieces of base material. So when done properly on steel, it results in a weld stronger than the surrounding base metal. So this rod here looks like it may have been a 6010, may have been something else, but you can see this kind of V shape they got going on. That tells me they're moving a little quick. Certain rods, that's fine, 60-10, especially if it is a open root metal or open root joint. What should we see? We talked about how it can provide stronger than, or your weld should be stronger than your base metal. This is pretty common. So rods are going to have a 70,000 pound tensile strength. If you're running a 70-18, if you're running a 60-10, it's going to have 60,000 pounds. If you're running 110-18, it's going to be 110,000 PSI is the strength it's going to take to rip that weld apart. But often what we find here is welds will break on what's called the HAZ, heat affected zone, which is just outside of our welds here. There's a weld on the underside of this plate, and you can see this kind of bluing here. And there's a weld here, but you can see kind of the bluing line right here. Welds are going to break there. It won't break on the weld. It's very, very rare that a weld breaks in the middle of a weld. Usually the steel base metal has a strength of about 45,000 PSI. And this is going to be, 70. So at minimum 70. I'm trying to talk about slag quickly. Slag is a combination of the flux coating and impurities from the base metal that float to the surface of the weld. We talked about the agitation of the puddle, that kind of dancing around it does. Well, it floats all that garbage up to the top and it gets stuck in the slag. Slag solidifies. It's almost kind of glassy. You chip it, it cracks like glass. The slag also slows the cooling rate of the weld. We don't want welds to cool too fast because then we get things like perlite and martensite forming in there. Those are two spherical, basically defects, hard little balls, nodules we don't want in there. And what that does makes our weld more brittle, takes away its ductility, and it's more likely to crack if we have high amounts of martensite or perlite in the weld. So slag can be chipped away with a wire brush and cleaned off once you're done or when it's hard. This needs to be done after every single 70-18 weld we do. Any weld we have a flux on it, we need to clean it afterwards. Otherwise, we risk something called slag entrapment. So if we're working on a deep joint, so we got to put 6 passes in there total to fill it up. First pass goes in okay, second pass goes in, there's a bunch of junk in there, and you kind of chip it off and you weld over it 3rd, 4th, and 5th passes. So that stuff is stuck in the middle of that weld. Kind of like jelly in the middle of a jelly donut, right? You don't see it from the outside, but it's in there. That's what we don't want in a weld. That's going to take major amounts of strength out of that weld, and it's just not good practice at all to ever have any junk in your weld. We want solid weld material the whole time. So I'm going to talk about an application activity here and see how this goes. So I'm going to get you guys to call it out if you can. Number 1, what was that material called? You can throw it in the chat too if you want. All right, so save some time here. Number 1 is going to be flux. That is the stuff on the outside of the core wire. Number 2 is going to be your arc. That transfers the metal across the or from the core wire to the base metal. Also stabilizes the arc. Actually, no, sorry. The arc is arc just transfers the material across. Number 3, we have our molten weld puddle. That's that puddle that's dancing around, floating that slag up on the top. 4 is going to be your shielding gas. That's what stabilizes our arc for us and prevents atmospheric contamination of our welds. 5 is going to be our solidified weld material. That's a mixture of the base metal and our filler metal. 6 is going to be slag. That's that hardened glass-like material on top of our weld that we chip away. Controls the cooling of our weld and traps those impurities that we did not want in our steel in slag. So that is that. Equipment setup. We're going to talk a little bit about this, and then we're probably going to stop after this. So in this whole setup here, if we're working with a dedicated shielded metal arc welding machine like this one, what we need to do is first step is we got to turn our power supply on. That's our arc welding power source right here. To turn that on, we obviously need to connect our plug to our power source via our input or our power cable. Number 2 is connect a work clamp, because we know we're going to need that regardless. That system will not work without that ground clamp. So we got those. Next thing is we need to select our electrode. So what are we welding is going to determine what electrode we do or we choose. But when we choose our electrode, we need to figure out a couple things: what type and what diameter. That is going to basically dictate our number 4. Number 4 is our polarity and our amperage. So if I was choosing 3/32 6011 rod, I'd want my polarity to be electrode negative, and I'd probably want my amperage to be about 65 to 70 amps. If I was doing a 1/8 7018, I would probably want an electrode positive polarity, so EP. My amperage should be 125 amps. So that is determined by the type of electrode. So we need to set our polarity, set our amperage, and then we basically insert the electrode holder, and start our welding. But we got to do it in this order because certain things are affected by the choices we make. So settings on the machine, we could have alternating current, which is AC. We could have DC electrode positive, which is DC plus, and DC electrode negative, which is DC negative. We got our amperage output. Those are generally the settings on these older machines. Some machines will also have things like arc force, hot start. Arc force could be called inductance as well. But we have some variables that we control. Now, the operator controlled variables are things like work angle, travel angle, arc length, and travel speed. It's how you move that rod across that weld joint, how you position yourself, and how you attack this project. So we're going to get into that another day. We're going to talk about striking arc, making a weld next class. So we're going to wrap this up here, folks. I hope you're all able to catch most of that. And I want to say thanks for popping in. So this is, there's going to be a quiz on this stuff. I'm going to build the quiz. It's going to be based off of this presentation. We might do this presentation in a couple parts. But yeah, it will be recorded. It will be up for you for reference material, as well as a standalone slideshow. So I'm going to do that for you. I'm going to stop this recording right now.